Our opening reading this morning is by Commander V.K. Jaitley, author of the book We Can, We Can. The moment we say think global, it also means let noble thoughts come from all sides, and let us be ready to learn from others. Let us give up the rigid attitude of my path alone is the correct one and all others are wrong. It is very important that we come out of narrow silos of thinking, embrace what is good anywhere in any part of the world, and give up whatever is not good for humanity. Love this planet. Love nature. Look at the various communities in the world. There is awesome diversity. So many languages, so many religions, so many races, so many sects and subsects, and so many isms, and so many ways of interpreting the same thing. Doesn't that make the world interesting and make it beautiful? May this flame, symbol of transformation since time began, fire our curiosities, strengthen our wills, and sustain our courage as we seek what is good in and around us.
Good morning, everyone, again. Today's first hymn is Celebrate Spring, so please celebrate spring with me as we sing Lo, the Earth Awakes Again, hymn number 161. And thanks, Francis, for showing the words on the screen. Lo, the earth awakes again, Alleluia, from the winter's bond and pain, Alleluia. Bring we leaf and flower and spray, Alleluia, to the dawn this happy day, Alleluia. Once again the word comes true, Alleluia. All the earth shall be made new, Alleluia. Now the dark cold days are o'er, Alleluia. Spring and gladness are before, Alleluia. Change then mourning into praise, Alleluia. And for dirges anthems raise, Alleluia. How our spirits soar and sing, Alleluia. How our hearts leap with the spring, Alleluia.
Reverend Sean Newton of the First Unitarian Congregation of Toronto, in the Sharing Our Faith program, acknowledges visions of 5 aspirations to live by. These aspirations are also our monthly themes. I invite you to consider each one. We aspire to be deeply connected to our sense of what is sacred to each other and to our wider communities. We aspire to be radically inclusive, welcoming all people in the fullness of who they are on this journey with us. We aspire to be actively engaged, fully and heartily occupied with the work of love and justice before us. We aspire to be theologically alive, awake and opened to new and deeper understanding of life's meaning. And we aspire to be spiritually grounded, firmly rooted in the sacred soil of life, that we may be nourished and strengthened to take up our work in the world.
Are we alone? Is one of the great questions, along with and related to why are we here? Or how did we get here? And what is our future as a species? Speculation about the life elsewhere goes back thousands of years. The idea of the plurality of worlds originated with the ancient Greek philosopher Anaximander in the 6th century BCE. It did not gain much traction at the time, even though the atomists Leucippus and Democritus promoted the idea a century later. Plutarch is better known for his biographies, but in his De Facie in Orbe Lunae, or the face on the moon, he speculated about possible lunar inhabitants. In the 2nd century of the Common Era, Lucius of Samosata wrote A True Story, the earliest known work to include travel to outer space, extraterrestrial life forms, and interplanetary warfare, although it is more of a satire than science fiction. After Copernicus and the realization that the Earth was not the center of the universe, Thomas Digges, an English astronomer, and later Giordano Bruno, proposed that the stars are suns like our own, possibly with planets orbiting them. Bruno was burned at the stake as a heretic in 1600. Carl Sagan called him a martyr to the plurality of worlds, although that wasn't his only heresy, apparently. While Darwin and others raised doubts about the rise of intelligent life elsewhere, new scientific discoveries suggested that the multitude of stars visible by telescope were similar to the sun in composition. Closer to home, the observation of ice caps on Mars in the 1700s, followed by the observation of markings on Mars, described as canali, or channels in the late 1800s, led to all kinds of speculation about Martian civilization, particularly when canali was translated as canals in English from the original Italian. Popularized by the astronomer Percival Lovell, this gave rise to the fictional Mars of Edgar Rice Burroughs and Ray Bradbury. That's a cover from one of the editions of the Martian Chronicles. This was even after the canali were dismissed as an optical illusion, and spectroscopic analysis found no oxygen or water vapor in the Martian atmosphere. Mariner 4 found in 1965 that Mars was heavily cratered with a thin atmosphere of mostly carbon dioxide. And that's a picture of the surface of Mars. I believe it's from one of the Viking landers. Venus, shrouded by a thick atmosphere, gave science fiction writers much scope. It was described as habitable and primarily ocean, swamps, or desert. The Soviet Venera probes beginning in the 1960s and eventually landing on Venus showed that Venus was an extremely hot, dry desert planet with sulfuric acid in its atmosphere. So not exactly conducive to life. This is an artist's impression of a composite of one of the pictures from one of the Venera landers. A possible ecosystem for the atmosphere of Jupiter was also suggested by Carl Sagan and Edwin Salpeter, consisting of sinkers, floaters, and hunters. Probes of the outer planets found even stranger worlds, such as Europa, a moon of Jupiter, and Titan, the largest moon of Saturn. More on them later. Life as we know it shares the following characteristics: order, sensitivity or response to the environment, reproduction, growth and development, regulation, tendency towards stable equilibrium between interdependent elements, otherwise known as homeostasis, and energy processing. It requires an energy source to allow liquid water to exist, or possibly liquid methane, and to fuel chemical reactions or metabolism. Complex chemistry with elements heavier than hydrogen and helium, and carbon as building blocks for complex organic molecules, and benign environments giving protection from harmful radiation, such as ultraviolet light. Ultraviolet radiation can damage or break complex molecules, causing mutations that may inhibit the emergence of complex life. Protection from ultraviolet light is afforded by an ozone layer or by the life being underwater or underground. Life, including complex and intelligent life, may be common throughout the universe. If Earth is a typical rocky planet in a typical planetary system located within a non-exceptional region of a common barred spiral galaxy. There is some evidence, although obviously not conclusive, that there could be simple life elsewhere, just in our solar system. Organic compounds have been found not only in meteorites, but also in spectra of gas clouds thousands of light years from Earth, indicating the building blocks of life are common throughout our galaxy. Organic chemistry is not life, though. According to the rare Earth hypothesis, places that enable complex, let alone intelligent life, are extremely rare, and conditions have to be near perfect for complex life to evolve. For example, the habitable zone of our solar system, essentially where liquid water may be found on planetary surfaces, may be very narrow, and such zones may be rare in other solar systems, despite the thousands of planets that have already been discovered orbiting other stars. On the other hand, life on Earth is present in a variety of extreme environments, including deep in the crust, high in the stratosphere, and in highly acidic or extreme temperature environments. Starting in the late 1970s, the later Pioneer missions, Voyager 1 and 2, and subsequent unmanned probes gave increasing data about the outer planets and their moons. Surprisingly, it was found that a number of these moons, including Europa, as mentioned previously, Enceladus, which is a moon of Saturn, and Triton, a moon of Neptune, have liquid water oceans that could harbor life beneath an icy surface, possibly associated with geothermal vents, similar to some life forms on Earth, the geothermal vents or at the bottom of the ocean on Earth. The heat to produce liquid water comes from either radioactivity or tidal forces. From what we know about other planetary systems, such icy moons may be more common than rocky planets like Earth that are in the habitable zones of other planetary systems. One of these probes actually landed on Titan, the largest moon of Saturn. It has a thick atmosphere, mainly nitrogen, with methane lakes and seas on the surface, and clouds and precipitation, essentially weather, methane and ethane rain. This may allow for life forms quite different from those on Earth, or at least the study of prebiotic chemistry in an atmosphere similar to that of early Earth. Titan may also have a liquid water ocean beneath an icy surface. How would we detect extraterrestrial life? One way would be through discovery of an artifact such as an unambiguous radio signal, or an alien spacecraft such as Arthur C. Clarke's Rama from the novel Rendezvous with Rama and some sequels. The Drake equation was proposed in 1961 by American astronomer and astrophysicist Frank Drake as a way to generate discussion. It essentially amounts to a summary of the factors affecting the likelihood that we might detect radio communication from intelligent extraterrestrial life. Reasonable estimates exist for the first couple of factors, the average rate of formation of stars and the likelihood of stars having at least one planet. But the other factors are highly speculative. Multiplying the factors together gives a number for the number of civilizations in our galaxy that we might receive communications from. Depending on what estimates are used, results range from very less than 1, which means we are likely alone in the galaxy, if not the universe, or millions of civilizations in our galaxy alone. The question is, where are they? Why haven't we received any communication from them? The last factor in the Drake equation is the length of time such civilizations exist. Even if intelligent life develops the necessary technology, a civilization may not last long. Given the situation on Earth, it is easy to think of reasons why, especially combined with what we know about great extinctions on Earth. The other way to discover extraterrestrial life is to either directly observe it or its fossilized remains, or detect various biosignatures such as isotope patterns, minerals, or atmospheric gases that require or may be indicative of biological activity. The presence of methane in the Martian atmosphere and the possible discovery of phosphine in the atmosphere of Venus may indicate biological activity, or it may result from non-biological processes. The presence of oxygen in the Earth's atmosphere is an obvious biosignature, at least for Earth. The Seeger Equation, developed by Canadian-born MIT astrophysicist and planetary scientist Sarah Seeger, is a parallel version of the Drake equation, focusing on the search for planets with biosignature gases detectable by telescope from Earth. And indeed, atmospheres of planets orbiting other stars can be analyzed, although with greater difficulty than stellar atmospheres. And even pollution, such as nitrogen oxides, could be detected. This would be considered a technosignature or a sign of a technological civilization. The Viking missions to Mars in the 70s had a number of experiments looking for biological life or microbial life. The first found what looked like metabolism, but the others could not find any organic material in the soil, at least to the sensitivity of the instruments. Since then, traces of water vapor have been found in the atmosphere, as well as a lake beneath the southern ice cap. Much evidence of flowing water and even oceans in the distant past have also been found. The Curiosity rover found organic compounds called thiophenes, which are primarily the result of biological activity on Earth. There has also been material ejected from Mars by impact events that travel to Earth to fall as meteorites. We know this because meteorites contain gas pockets identical to the Martian atmosphere. Some of these Martian meteorites exhibit what could be microfossils or other biosignatures. The jury is still out on both present and past life on Mars. Excuse me, but we may find out one way or another or the other in the next decade. The search for extraterrestrial life can be considered a free and responsible search for truth and meaning. Sarah Seeger found meaning by dedicating herself for the search for alternative Earths after the death of her first husband. The finding of it may help answer the question of how we came to be, if not why we are here. Extraterrestrial life is part of the web of existence, whether we are aware of it or not. The discovery of alien life may impact religions that believe in special creation. The discovery of civilizations more advanced than ours may give us hope that we will survive our current existential crises, even if there is nothing in that discovery that will directly help us address them. With respect to the inherent worth and dignity of every person, a few years ago, there was a proposal within the UUA to change this to every being. One of the arguments against this was that we should strive for equality between people before considering other beings. Perhaps we could simply regard other intelligent beings as persons, and that could apply to intelligent beings on Earth too. We should hope that they feel the same way, especially if alien life or alien intelligence, if these beings are far more advanced than we are. Thank you for listening.
Okay, so let us celebrate life in all of its forms and all of its locations with this song, hymn number 331, Life is the Greatest Gift of All. And thank you, Francis, for showing the lyrics. Life is the greatest gift of all the riches on this earth. Life and its creatures, great and small, of high and lowly birth. So treasure it and measure it with deeds of shining worth. Mind is the brightest gift of all, its thought no barriers mars. It seeks creation's hidden plan, its quest surmounts all bars. It rains the wind, it changed the storm, it weighs the outmost stars. We are of life, its shining gift, the measure of all things. Up from the dust our temples lift, our vision soars on wings. For seed and root, for flower and fruit, our grateful spirit sings.
Now that we are online, we welcome your donations and pledges in two different ways. First, we have set up the Unitarian Fellowship bank account to automatically deposit e-transfers sent to info@ufon.ca. Secondly, you can write a check and pop it in the mail. Our charity for the month is Inspire, a national Indigenous registered charity that invests in the education of First Nations, Inuit, and Métis peoples for the long-term benefit of these individuals, their families and communities, and Canada. If you would like to donate to the designated charity for the month, please note that on your e-transfer or check. We are grateful for your offering. Our closing words are by Swami Vivekananda, who was an Indian Hindu monk, one of the most celebrated spiritual leaders of India, and a foremost free-thinking philosopher. He is credited with bringing Hinduism to the status of a major world religion during the late 19th century. His succinct, reflective words are, talk to yourself at least once in a day. Otherwise, you may miss a meeting with an excellent person in this world. We extinguish this flame, but not the light of truth, the warmth of community, or the fire of commitment. These we carry in our hearts until we are together again.
And now I invite everyone to switch to gallery view and sing our closing song, Carry the Flame of Peace and Love Until We Meet Again. Then we shall see a world of light and a world of joy. Carry the flame of peace and love until we meet again. Carry the flame of peace and love until we meet again. Then we shall see a world of light and a world of joy. Carry the flame of peace and love until we meet again.
Hi, everyone. For those of you who don't know me, or may not know me, my name is Jane Naz, and I am here to represent the Canvas Committee. And the Canvas Committee consists of myself, Dawn Gayton, and Marla Thorburn. And I'm here to announce the results of this year's pledge campaign. But first, we're going to have a little fun. We're going to run a poll and ask you how well you think we did in the campaign. So I'm going to ask Tony to please run the poll.
Okay, and I'm going to share. Should I share the results?
Sure.
Sharing. Oh, or am I sharing them
I
now?
think it's come up. Yes.
Oh, okay. They're sharing
So,
automatically.
how lovely. We've got nobody who thought we were way behind the goal. So I'm glad everybody's very positive about that. 8% thought we were a little bit behind the goal, and 28% thought we were at the goal, and a whopping 56% thought we were slightly above the goal, and 8% of very positive people thought we were way above the goal. So thank you, Tony, for doing that. And so And that's wonderful. And let's see the big thing. Tony, can you take that down, or do I just have to click it off my screen? There we go. I got it. So let's see who was actually the closest. I'm going to ask Francis to run a PowerPoint that we have, please. Wonderful. Thank you so much. So there we have it, 88,164. I can see Deborah doing this. Yay! So we didn't quite meet our goal, but the wonderful news is that we surpassed last year's goal. So last year's goal was 85,000, and we raised 88,164. So I think we've got lots to celebrate. 75 members and friends pledged, and I want to sincerely thank each and every one of you. And if there's anyone who would still like to pledge, I'm sure Lise would be very happy to hear from you. She's saying yes, yes. Please get in touch with me. So now let's celebrate with a toast. So all of you, I hope all of you brought a glass. I can see Bev with a mug. That's good. I would like to make a toast to our beloved Fufon and all of those who have made a financial contribution to support our congregation. So to Fufon and those who have supported us. Well done to everybody. A sip. And there's lovely cupcakes that got delivered to Deborah and Lise. I'm sure they're going to have a sugar rush after they've eaten one of those. So I hope all of you have something, a little something to celebrate as well. So thank you once again on behalf of the Canvas Committee. I think it's been a very successful campaign. So thank you to everybody.